So what I want to talk to you about today is how can we harness the power of AI and programmability as we think about a software-defined edge. So I'm convinced that my cell phone actually knows more about me than my husband does. Perhaps I should ask him to ask it what I want for my birthday that's coming up soon. Clearly, we've cracked the code on discriminative AI and ML and creating recommendation systems, because this device knows what I want and my social media platforms know what I want before I do. In fact, some of the recommendations it makes are kind of scary. But increasingly, it's not just about these recommendation systems, and we're entering into a world where generative AI will help make a difference. Our lives are increasingly complex, but more importantly, from an industrial perspective, there is so much chaos around the world, and industries are trying to figure out not just how to survive, but how to thrive. And therefore, it's really important for them to be able to respond to changes in the marketplace, creating resiliency, as we talked about, as our colleagues talked about earlier, in their operations, reducing manual processes and human error, and generally everything that is associated with making more efficient operations. And clearly, AI will play a role in enabling those industrial demands. While AI will help to enable these use cases, it's also driving a need to distribute compute at the edge. When we think about applications like we heard about in the factory floor, predictive maintenance, operational resiliency, things like AR, VR, all of those, there are several changes that are driving the placement of workloads at the edge. But what's also happening is these applications are actually becoming more and more demanding. What's also changing is the fact that rather than just a static mode of execution, a lot of these are transforming into a dynamic mode of execution, where there's things like, computer vision as an example. There's a lot of real-time responsiveness required, especially when it comes to things like worker safety, as an example. But these workloads are not, simply changing in the way that they function, also where they function. They're becoming virtualized. We're hearing a lot of things like on the factory floor, where PLCs are getting virtualized to be deployed on general purpose compute. But this process of virtualization and consolidation of these applications at the edge leads to the creation of a flexible pool of compute and storage. But by enabling this kind of flexibility, you're able to actually right-size the infrastructure. Imagine what gains that can actually bring. But the compute isn't enough. When we think about compute and even AI at the edge, it's like having a 50-piece orchestra where each individual instrument can actually create beautiful music on its own. But if these things are executing side by side at the same time, it's actually cacophony. It's capable, this whole instruments ensemble is capable of making beautiful music, but it needs to be conducted, it needs to be orchestrated to create a symphony from cacophony. So when we think about all of these different compute elements, especially when you think about it in an industrial environment, these individual compute elements actually are going to create a nightmare when it comes to the lifecycle management, the deployment of these applications, upgrades, troubleshooting, safety, security. It's going to be difficult to harness the power of this compute in a meaningful fashion. So from an edge perspective, for this edge to function, to create to be able to harness and fulfill the promise of edge compute, you really need unified management. So IT processes, we've learned a lot from IT, processes that provide flexibility, agility, and scale, and we're starting to apply that in many other places. But how do we apply what we've already learned in IT to tune it to deliver that seamless experience at the edge? So unifying this with visibility will allow industries to implement monitoring, pull-based orchestration and management. And in fact, manufacturing is a great example of where zero-touch orchestration can have a meaningful impact. So we talked about right-sizing the infrastructure. We talked about zero-touch orchestration. And that really is the two elements of a software-defined edge. But the magic will really happen when we can bring programmability into the edge. And what do I mean by that? Programmability at the network edge will allow us to actually deliver services that are tailored on a per user, per services basis. So services that are actually tuned to the requirements of the user or the application rather than just being limited by what the network is capable of. So if we look at how the future is going to evolve, especially with the usage of AI capabilities, things like augmented reality, as one example that I've already talked about, enterprises will need to have a direction and evolution beyond the current deployment of just having storage and edge. They will require dynamic, real-time configurable connectivity. So the one-size-fits-all methodology on connectivity won't be able to provide the performance or the quality of service that is needed for these diverse range of applications that are going to actually reside at the edge. You need to be able to tune the performance, have a responsive network in order to deliver the services that are required. And at VMware, we call that the intelligent overlay. So let's look at how this intelligent overlay could work. So I think you need to play the video for me. So you can see an example. In this case, it's a public safety example where you have a car sitting, and actually we have an ambulance on our stand and Hall 3 M11, so please do come by and take a look at it. But in this example, you have a car, a patrol vehicle that's just sitting there. Now, it's not sustainable to be able to provide real-time, high-through-put video feeds back to a control center. So typically, they're just sending snapshots of photographs every 4 to 5 seconds back to the control center. Now, if you think about what that means in terms of what could you do if you actually had a programmable interface? Is this video? Okay, it's running. So in this case, you have live video that it could be triggered when an action occurs. So in this case, the officer's making a stop. They had low bandwidth video running, but as soon as the action of turning the siren on, turning the lights on, triggered a feedback to the command center where you actually had high performance video. Oops, we have a runner there. And so what ends up happening is with this programmability at your fingertips, especially with a 5G network, you could actually do more proactive actions in response to something that's happening, or be more proactive rather than just waiting for something bad to happen. And so this is just one use case, but you think about how this could be applied in manufacturing, in retail, in healthcare. And you think about healthcare patient monitoring or retail enterprise security. All of these use cases can be enabled with robust programmable connectivity. And I think that combination of bringing together the right-side infrastructure, the simple provisioning and deployment of applications, and then the connectivity to match allows you to deliver tailored services at the edge. So if we think about the future, what would our grandkids say if they were here at MWC 2054? I hope they would say that we did everything in our power to harness the capabilities of AI to deliver meaningful outcomes that is going to solve some of these very real challenges like climate change, like efficient resource utilization, that we were able to really harness this power that's at our fingertips to deliver the right outcomes, and that we got this right. with that, I think that was my last slide. Thank you.